2.6 is prove statements about segments and angles. They start with a proof is a logical argument that shows a statement is true. It's exactly what we've been doing, okay? Two-column proof has numbered statements, so very similar to what we were doing, with the statements on one side and the reasons on the other side. Okay, so theorem 2.1 is the congruence of segments. It's reflexive. There is a symmetric. And there is a transitive. I'm not going to write them all out. I'm going to write the page where you can find it. So, the pages where you can find this are 113. And I'm going to show you the other one. Theorem 2.1 is the same thing, congruence of angles. It's also page 113, and they also have a reflexive, a symmetric, and a transitive. These are the theorems right here. Okay? The reflexive says, just like the one for the mirror, for any segment AB, the segment AB is congruent to itself. If symmetric says if AB is congruent to CD, then we can flip-flop them. CD is congruent to AB. And transitive says if AB is congruent to CD and CD is congruent to EF, then AB is congruent to EF. So basically, if the middle two are the same, we can drop the middle two and have the last two be congruent. Same thing for angles. The only difference is instead of segments, now we're dealing with angles. So for an angle A is congruent to itself, mirrors itself. If A is congruent to B, then B is congruent to A. So they flip-flop. And then the last one, if A is congruent to B and B is congruent to C, then A is congruent to C. Again, the transitive, if the ones in the middle are the same, you can drop them out. So what I'm going to do is go over an example for you so you guys know how to do it.
You put, for congruence of angles, you put 2.1.
Yeah, the theorem is 2.1. It says theorem 2.1. It's listed on page 13, 113. Even though this is 2.6, the theorem is called 2.1.
For both of them?
The second one should be 2.2. Yeah. Thank you. Alright, so here's the example. Here's the given. M is the midpoint of AB. And they give you a picture. Okay? Prove that AB is 2 AM. Okay? So, we start with our statements. And our reasons. So the first statement is always going to be the given. So, M is the midpoint of AB. And we can write given. So that's step 1. Step 2. AM is congruent to MB. I can say that because the definition of a midpoint says that those two are congruent. So definition of a midpoint. Now, in part 3, I have to say AM equals MB because I cannot just assume that the measurements are equal. I have to say that's the definition of congruent. Hang on, I'm going to finish this proof so that you guys can do your homework. I expect you guys to keep taking notes. So, you can say these two measurements are equal because of the definition of congruent segments. If they're congruent, their measurements are equal. Okay? 4. I'm going to say AM plus MB equals AB. And that is the segment addition postulate. Sorry, it should go down here. If you have two segments that make up a big segment, their measurements added up equal the measurement of the big segment. Five, we can say AM plus AM equals AB. What did we do here with the MB and the AM? Substitution. Good. So, substitution. Property of equality. And then the last step says 2AM equals AB, and that is the distributive property because it's backwards. So, go ahead and do the best that you can on your homework tonight.